day. In today's video, we'll show how we can apply real-time fading on signals using Keysight's N5182B MXG. So what we have on the screen here are the user interface. On the top left-hand corner, that is the interface of our MXG, and on the right is our N9010B EXA. We also have the N7605C Signal Studio, which will provide the real-time fading to signals on the MXG. So let's talk a bit about the physical connection that's required for this to work. So I have here the RF output port connected to the RF input port from the signal generator to the EXA. On the rear end, you will have the 10 MHz reference out and in connected together using BNC cables, as well as event 1 out of the signal generator connected to trigger 1 in on the EXA or spectrum analyzer. For today's video, I'll showcase using LTE signals, and for that, I'll just turn on the VSA app on the EXA so we can see a few more matrix. So let's get that running. So while that's running in the background, let's check on what we have to do here on Signal Studio. So you will be prompted with a configuration setup. Let me just close this. As I've previously set this up, went straight into the interface, but say if you have not set the instrument connection up, let's just go ahead and do that. So if you go to system configuration visit, you can then hit next. If this is a new connection, you can go ahead, hit new, enter the IP address, do a test IO, and proceed to add it. As I've already done this, as you can see here, it's available, so I can just click on it, just show you that's the IP address that I entered, and that's what's detected. So that's good. I'll hit finish. We are now ready to go ahead and set up for fading. So before we can apply any real-time fading, we'll have to have the signal or waveform already running on the MXG first. Otherwise, the Signal Studio application will not work. So to do that, we'll have to first go to mode, and you'll have to turn on either the dual up, or custom modulation, or any of the real-time applications. So if you actually hit more, that's where real-time fading is. So for this example, I'll just go ahead and turn on a dual ARP signal. We'll first select a waveform. I already have some of these waveforms loaded into the RAM. If you do not have this, you can go to Waveform Segment Explorer. Let me just do that. And then click through the internal storage and load it across to the RAM. I've previously loaded the LTE ACP signal, so that's what I want, and I'm happy with that, so I just hit return. Now I just go to the LTE signal that I want, or I'm after, and hit select. So it'll tell me that the LTE waveform has been selected. I'll turn on ARP. Once we have that turned on, we can hit back to the fading application. We have already done the instrument connection. This is the default values. We can leave the frequency as is for now, as this will be changed once we've selected a certain channel model. But I will just change the amplitudes here. And I'll set this to turn on when we hit fader on. So let's have a look at fading. So it will tell us that that's the default, but that's not what I'm after. So let's just go ahead and select LTE. I'm just going to pick a base station. Let me do base station 5 in pedestrian, and then it'll change my carrier frequency to 869 megahertz. So before I turn this on, let's head back to the VSA section. I'll go ahead and change the measurement type from vector to LTE. So that's under cellular, just so we can see a few more matrix or results beyond the RF spectrum. I'll change the grid view, cancel that, 3x2, there you have it. And just so we are looking at the right carrier frequency, I'm going to match that to the signal generator. So now that I'm happy with this setup, oh, let's just look into fader path as well. By selecting the channel models, we've predefined some of this. So the fading tab is Rayleigh. We have classical spectral shape. There are a few different spectral shapes you can change. You can also change the delay type. Channel bandwidth is about 80 megahertz. Delay, loss, vehicle speed, Doppler frequency. If the carrier frequency coupling is based off vehicle speed or Doppler frequency, phase shift, and frequency offsets. I will just leave this to the default settings or setup. So let me just hit back to this tab and we'll turn fader on. You see it downloading and applying the fading. So once that's done, we can see there is a signal there. I'll just do an auto range up here so that the spectrum is a little more visible. I can perhaps tune the span down a little bit. And from here, you can see every now and then the fading is applied based off the paths that has been enabled. So if I turn fading off, there's no fading applied or no real-time fading applied to your comms signal. So one thing to note here is with the real-time fading application, there's no option to download or save this waveform, mainly because we're applying real-time fading, so it's not something you can save on the app. What you can do is save the states on the MXG and recall that waveform with fading added on. So to do that, let me hit back to the MXG and I'm just going to save the state under register 2. So I'll just resave this. You can pick the right registry or any registry that's available to you. I'm just going to overwrite this registry. So let's resave that. You can see that matches the time there. Now, if I went ahead and do a preset that would clear off my measurements, I can now go recall, select the registry I want to recall. I now have the signal back. To turn that on manually on MXG, if you do not have Signal Studio turn on, let's go to mode, hit more, real-time fading, and that would be on. Give it a few seconds as it needs to apply the real-time fading. As you can see, the fading is applied again. So if you're working on automating this or you need to work with Skippy commands for this is the Skippy command to turn fading on and off. So I have a Keysight Interactive I/O turned on. It's just to send and read anyway. So that's the right model and that's the serial number. To turn fading on and off, I can first do a query to check that fading is on, which we have, and that shows me that it's on. So now I can go ahead and do off. And you can see fading is off. Just to query it again to double check, it tells me it's off. So this is the Skippy command you need in order to turn the fading on and off. So if we just want to play around with this, let's go ahead and turn on a second profile and save it to register 3 this time. So instead of band 5, let me go ahead to band 9 and hit pedestrian. Before I turn that on, let me just create a new measurement specifically for this band. So cellular again, let me just pick LTE. I'm just going to readjust the grid layout. This is from band 5 and we'll want to look into band 9 here. So it says this carrier frequency is 1.8449, so I'll change that to 1.8449 gigahertz. Let's do a run. So there's no signal turn on. If I do this and apply, you can now see there is another signal at 1.8449 and that's the second profile for band 9. Let me just do an auto range again. we will also just reduce the span. So fading's turn on, as you can see. We can do that. We can switch that off and it'll be off. So let's just keep fading on this time. And I'm going to save this as a second state. I'm going to save it to register 3. So that's been resaved. So if I do a preset and do a recall, this should now pop up with fading on. Alright, so let's just go back to measurement 1. That would stop measurement 2. Let's recall register 2. I will run this. And because if you remember I had fading turn off, this has no fading turn on. But this is how you can then save as a few profiles to turn on and off without having to re-download from the Signal Studio application. That's all I have for today. Thanks for watching.